In order to build the Ark-BoT, you need to start with the cycloidal drive. This is the gear drive which drives each of the primary joints. So to start with, we get this section which has these little marks, these little indents for the thread inserts, and we push 6 thread inserts into the surrounding ring using either a soldering iron or a specific heat press device. Once that's done, we put 3 more on the other side of, well, not the other side of that same part, but this is the part which will hold the motor. You put 3 on there. Then take 6 M335 screws and screw them through the top section. This is where the bearings and spacers are going to go. You need 12 of these 693 2Z or ZZ, they're the same, it's just different standards, I believe, and put 6, then followed by 6 3D printed spacers, and then 6 more on top of that. These are the rods which the eccentric discs are going to spin around, or she'll lock them in place, they will not spin around them. Take the metal section which connects to the motor and this motor connector for the interior rod, and take these M3x8 screws, 4 of them, and screw all 4 through the plastic into the metal to create this connection. The internal offset rod, it consists of 3 parts. Putting these medium bearings on the parts like shown in this video here is how you assemble the interior. Taking the top, you make sure the top is aligned with the top, obviously, so that it does not fall off when it is in motion. Click the 2 halves together, they will be offset. This is intended. And make sure that they both spin freely, 1 click together. There is a marking on both of them saying top. These need to be 180 degrees out of phase, so these need to be opposite each other before you push them in. This is essential for alignment and accuracy. The whole thing will not work unless they are 180 degrees out of phase for each other. Then taking the top half and the final 4th bearing, put them on and screw it together. Finally, it should look like this. You've got the final piece of the offset rod which connects to the motor, and that just pushes in there. To complete the interior, you need to take this screw, goes into the motor, so goes all the way through, as seen here. And to ensure that the plastic, which is keeping it offset, the interior rod, to prevent that from snapping, we put 2 screws through each side just to hold it all together. Finally, the cycloidal drive will look like this. Spinning the interior rod should move the exterior. Moving on to the assembling of the base, turn the base over and take one of these massive bearings, 6, 8, 10 2RS bearings, and push that into the bottom. Make sure it still moves freely. Then take these 3D printed bearing holders, and they have an indent so that they align properly inside of the part, and take these M316 screws, 3 of them, and screw them into the exterior just to hold it in place. This prevents the bearing from falling out and keeps the whole system working. Well, keeps the whole system stable. Take one of the cycloidal drive interiors and push that inside until it cannot be pushed any further. Take another one of the 6, 8, 10 2RS bearings and push that on top to prevents horizontal motion. Again, take another one of these bearing caps, put it on top, the same M316 screws, screw it in, and this holds the cycloidal drive in place. Take one of the motor holders. There is a specific one for the base, as can be seen here. This will screw this into the cycloidal drive using M316 screws. And once that's complete, it should look like this. This is the start of the assembling of the base. This is the first joint practically complete. Then take this part and attach it on top. This is the link between the base and the first joint. This is what holds it together. This section is the next part for that assembly, and requires these screws here, as listed on the screen, to assemble. Take a quick break from that. We need to make 4 cables, each at 40 centimeters long. You cut the wires like so. Strip the ends of each of them. Take some wire and solder it all together so that they look like this. Make sure that the solders are secure. Use electrical tape to prevent any shorts and to make a stronger connection. Next, we want to build the exterior of the cycloidal drives. So take the motor holder, this assembly, and screw it into the motor using the screws provided with the motor. To make the exterior, you take the exterior and use these 6-8-10 bearings and push them into place. The motor cap here is a thinner one for these assemblies, and just pushes in place into there, and then screwed in with the M3x6 screws, as can be seen on screen now. Once it's done, the bearing should be secured in place, and the interior of the cycloidal drive can be pushed in. The top side should be on the top. Threaded inserts should actually be in place in these 3 parts, so we'll just quickly do that. Once that's done, take another one of these 6-8-10 bearings, put it on top, and take the casing, the top casing for the exterior of the cycloidal drive, and place that on top. Make sure the screw holes are aligned, and insert the M3x12 screws into the holes provided. Turning it back over, we have the motor holder. Exterior side, there should be a bit of text saying bottom. Make sure that is at the bottom of the motor. Taking 3 M316 screws, screw it in to hold the motor holder to the cycloidal drive. Make sure to screw the motor screw all the way through so that it is connected with the motor to prevent it from falling out. To do a sanity check, you can take a pair of pliers and put them into the 2 screws on the side, not into the plastic as this could risk damaging it, and turn it. If it is turning and everything seems to be working, then that is a good thing and it's successful. Make sure to build 2 of these cycloidal drives, one for the base of the robot, connected to the part as seen on the right, and one for the second joint of the robot as seen on the left. For now, we will take the first joint, the one which was seen on the right, and assemble it with the base joint. Take one of the 40 centimeter long wires and thread it through this hole here. This keeps the cable management tidy and doesn't leave hanging wires. Fold it over to make sure there's enough give so that when it turns it does not get caught or break or damage the wires. Push the wire through this hole, make sure that none of the wires get caught in between the plastic, and secure the two halves together using M3 times 12 screws. Make sure to configure the motor. This is motor number 2, so this has to have the ID number 2. Go to the GitHub docs to see how to configure the motors. For this section, we are going to put 3 T-nuts into the plastic to secure the aluminium extrusion to this part of the robot. Take the 20 centimeter long aluminium extrusion and making sure that it does not get caught on the wire, push it into this gap, making sure that the T-nuts slot in between. Make sure to push it all the way down. Then tighten the T-nuts to ensure that they turn 90 degrees, as seen here. This ensures that the aluminium extrusion will not be going anywhere and is secure inside of the assembly. For the next part, we're going to go back and take the 2 halves of the cycloidal drive for the second joint. Using the pliers, we move the motor around just to make it a bit easier to put the wire in. Thread the wire through, give it a loop to make sure that it can rotate without getting caught. Push the wire through the hole on the plastic in the other half and put it on top. Making sure not to catch any of the wires in the assembly. Using 3 M3 times 12 screws, we're going to secure the 2 halves together to complete the second joint of Ark-BoT. Again, configuring the motor using the driver boards, we configure the motor for what is motor number 3. So this will have ID number 3. Attaching this joint to the first link is the same as putting the original aluminium extrusion in. We take 3 M3 nuts, put it all around apart from the wire side, thread the wire of the first link through this gap in here, so that it can to continue keeping wire management nice and tidy. And then you can push the 2 halves together, making sure the wire does not get caught on the extrusion. This is very important, as if it gets caught, it can get damaged when you're pushing it in. Tighten all the screws to make sure that the extrusion cannot come out, and plug in the wire into the motor, completing this section of the Ark-BoT. Next is assembling the forearm. So the first joint which needs to be created, you need these parts for. Taking this half of it, of the joint, and this is the motor holder equivalent. Screw this in using the 4 screws provided with the motor, and taking one of these 6706 2RS bearings and pushing them inside and making sure that it's still free to rotate. Take the motor assembly and the housing assembly and connect them together. There should be 2 halves of this. For now, plug both wires in and configure the motor. So this is motor number 4, so ID number 4. Again, go to the GitHub repo to see how to configure these. There's actually an error in this video. That short wire going through the bottom needs to be the long wire from the previous joint. It's corrected later, but is an error at the moment. Take 4 M3 12 screws and connect both of these halves to the housing. this should look like this as the final piece. You have two of these side links. The one which does not have an M on it is the one which doesn't have the section which goes into the brass bit of the motor. You take the two M320 screws and screw them into that part. This bit does not go onto the brass bit of the motor, so it does not have any jagged edges in the interior of that of the center of that metal circle. Put a bearing on the outside. Take the one which does have an M on it. This is the side which does clip into the motor. Take two M316 screws and screw them into the metal section. Again, taking another 6706 bearing and placing it over the surrounding edge. With the section with the M on it clips into the side with the brass bit of the motor, the bit which moves, and taking an M320 screw, we can screw it through the center hole to secure it to the motor. The next section you take is another motor holder. So you screw the two halves together, and this clips on with 3D printed clips. They clip together. To secure them, however, you do need to put two M312 screws through the two holes. This new motor needs to also be configured. This is motor ID number 5. As previously stated, go to the GitHub docs to see how to configure these. Take the other half of the links and connect them together. Again, clipping it into place on the upper component, and again another two M3x12 screws to secure them together. You should check to see if it moves as seen in the video, as this is correct. Next is the rotary joint. Very similar to the previous joint, there is a motor holder, so again screw the motor into this section. The main housing, you take the previously created joint, and this bit you need to take another 6706 bearing, put it inside here, and take the housing, screw a metal motor connector to it using two M312 screws as seen in the video. You then take this rotary component and place it until it clicks into the motor as seen here. Take a singular M316 screw and push it through the center to secure it to the motor. This should now rotate as seen here. Next is to assemble the rest of the housing around it using M312 screws again. Configure this motor. This is motor number 6. This is the 6th degree of freedom. So ID number 6, again, go to the GitHub docs to see how to configure them. This wire on the left here should be one of the 40 centimeter long wires. There is a mistake in this video where it's using the short one, and it should wrap around and then plug into the bottom of the previous motor. The next one should be this length. You plug this in here, making sure that it goes straight upwards as to not be in the way. Put the other half on, screw two M312 screws in, and that will be that. Now for the base of the claw, you take a motor and screw it into this section here. This is motor ID number 7 and must be configured the same way as all the other ones. Take 6 M3x6 screws and assemble it with these two sections to connect. This will connect it to the previous joint. Take the two links, and these two links on either side are assembled the exact same way as the previous one. The one with the M on it takes the two M316 screws and goes into the section which connects to the motor. The other one takes M320 screws and goes into the section which does not connect directly to the moving part of the motor. Take the 6706 bearings and put them inside here, or inside there, and then take one M3x20 screw to secure it to the motor. And similarly to the other joints, you connect using the 3D printed clips, you connect the claw to the other side, plug the wire in, secure the clips, the 3D printed clips, with the M3x12 screws, as seen here, and do the same for the other side. Now, connecting the forearm to the previous section, again using M3 T-nuts and the 10cm aluminium extrusion. Push it together, ensuring that the wire does not get caught. And then screwed and tightened to make sure it can't come out again. This is the video of fixing that error earlier with the short wire. So the green, white and black cable is going into that motor there. Then assemble the two halves the same way. You have to just use the M3 T-nuts and screw it in here like this. And now the two sections are complete. Returning to building the rest of the claw, we take this section and the remaining 6802 bearings, which should be the leftover ones of the 20 which was recommended to buy. Take the threaded inserts, put those in, then to prevent the bearings from falling out, we've got these caps which screw in as well. This component runs on the runners and makes sure that it moves. You make two of these assemblies and then take the runners and ensure that it actually does move fluidly on the runners, as seen here. Take the remaining parts. This assembly is the linkage for the claws. So it translates the rotary motion of the motor and turns it into the linear motion of the claws to make parallel grippers. This section here connects to the motor. So take the links and start putting them together as seen in the video. The links must move smoothly around as they're not supposed to be rigid. Do this for both sides. Then put two thread inserts into each of the fingers of the claw. Take two M316 screws. They go through this part which holds that joint to the runners. And they screw all the way through, finally screwing into the claw itself, as seen here. You put the screw on, you put the finger on and screw the screws into it. Do this to both sides and make sure that it moves smoothly, as seen here. Take the linkage and place it over the two extrusions and take the caps to prevent them from falling out and screw them in. Do a sanity check by turning the center and making sure that they both connect, that the two fingers connect in the center. Attaching it to the rest of the arm, the metal motor connector bit needs to clip into the motor. Once it connects in, take 6 M3x10 screws and screw them into all the holes in the surrounding to connect the two halves together. Make sure that it opens and closes by rotating the center bit, and this will conclude the assembly of the robotic arm. Once it's done and you've finished the calibration and setup, which can be found on the GitHub doc pages, you should have a moving robot which looks like this.